Hi everyone, welcome back to Abrar Knowledge channel. Today we are going to discuss about regression analysis. It is a part of the statistic and also widely used in Six Sigma, right? So regression we are going to discuss is the single regression, and in the next video we will be talking about the multi regression also as well. So to have a regressions, one of the precursor point is the variable must, all the data set must be variable, whether it's X and Y, both must be variable. Only then we'll be able to do the regression analysis. And so in this one, I'm going to do all these model, linear, quadratic, and you also have something called cubics. In all the three, we are going to discuss about it. And the key terms we'll be using it R square adjusted, and VIF, variant inflations factor, that is VIF, that is been there only for the multi regression that we will be discussing in detail in the upcoming video. P-value and sum of square, sum of mean, and all that we'll be discussing. We'll be doing it using the Minitab, and this is my fourth video on this regression topic. So there are three examples which we are going to discuss. Just to outline that what is the value we are getting it. R square we are getting 91. As you know that adjusted one is always less than the R square because the error and all that is getting adjusted. So 90.6. Similarly, in every cases you will find less than that. And quadratic and cubic gives better version. For example, in this 91 and cubic has given 99. 91 and cubic has given 93%. That means strong correlation. You all know that anything zero point 0.7 and above is considered to be strong correlations. In this case, this is moderate correlation because the value is less than 70%, right? So even if it is there in cubic, it has been accepted as a moderate one because actually you have a 70% as such. Okay, let's go to the data set. This is a three example. Number one, ad spend and sales, how much sales been generated. We are going to discuss. And the foam example, which we are going to discuss, temperature and the foam percentage in the cool drinks, and delivery time and the sorting time we are going to discuss. And this is also the food example, food delivery time and the sorting time. And this is all together the data set. So all these three. So the same data set I have put it up in the mini tab. Now let's start with the very first example. Example 1, 2, 3. Very first, add, spend and sales. Go to regressions, and we're going to do it single. So this is for the single one. If you're doing it multi, this is multi. So this is single one, and have a go. And I'm going to give F3 so that all the value will go off. So how much sales and how much ad being done, right? So first thing we are going to do it's linear, and I'm also going to do it the quadratic also as well, 4 in 1. So quickly we'll do and give OK. So in this one, so what you can see here is the value of R square. Yeah. So the value of R square 91.4, the adjusted is 90.6. That means strong correlated. And the data also like normal distributed, but versus plot actually should form the horizontal line. And it's not a perfect horizontal line, but it's still okay. And then histogram also says that one, and this is the distributions, and then there is a zigzag in versus order. So this all okay. So that means strong correlated. The same example, I'm going to give control E, and I'm going to do quadratic, right? So I'm going to select this one. The same thing, I'm going to do it in quadratic, right? So this is for quadratic, as you can see here, and degree of freedom is 1. Why? Because we are talking about two variables, so degree of freedom is the degree of freedom is 2 minus n minus 1. That means 2 minus 1 is 1. And then you have a sum of square, all these variables being squared up, and all these being so this is the f value, and p value is 0, right? So this is the better version, 99.4, and 99.4 we are getting it R square, and adjusted is 99.2, right? And the same thing, almost a similar graph we have got it in the quadratic as such, right? But here it's showing like more of a horizontal line compared to this one. So again, I'm giving control E. I'm going to do with the cubic one. Let's see the result of cubic. So this is the result has come for cubic. And so now you can see here again degree of freedom is 1 because two variables 2 minus 1 n minus 1 is that is 2 minus 1 is 1, and the sum of square f value and the p value you have got it, and this is for cubic. You can say cubic is 29.4, and the other two is showing like 0, right? But more importantly, when you're talking about cubic, it is you know 10, I mean e the power of 3 or exponential 3 or 10 to the power of 3, right? So 99.4, very strong correlation, and adjusted is 99.2, and this is pretty much a data set is normal and normally distributed, as you can see residual plots and all that, right? So this is the first example. I hope it is clear. Let's go. I'm going to minimize all these graph menu, and let's do it the same exercise using the second example, temperature versus foam. Control E, and I'm going to do F3 so that the window will get fresh, and the foam percentage and temperature. Let's do it with the linear, and I'm going to do it with 4 in 1, and then we can do the same thing we'll do. So in the storage, we don't need to store that fits and residual. If you want, we can directly show in the graph itself. So linear, let's go with that linear. So this is the linear one. As you can see here, this is also a strong correlated. You can see the slope line, that is y equal to c plus m into x, right? So y equal to mx plus c, or in other words, y equal to c plus m into x, right? So strong correlated, and adjusted value is 90.6 is very strong correlated, and degree of freedom is 1, and sum of square altogether is 1165. So mean square is the 1165, and then you divide all this and you will get the f value, and then you have a p is 0, right? So and then normally distributed, and it's forming that horizontal line, and 0 you can see, and slightly skewed positive side, and then this is the almost exact we have. So the data also normal. So let's do the C quadratic, and let's see the response. Same exercise, I'm doing it with the the quadratic. Quadratic has given that into 10 to the power of 2, right? And it has given little better response, sum of square 20.52, and then p value is 7 percentage. And you see here the important value in regression is r square 92.7. Initially we got how much we got 91, and now 92.7, adjusted is 91, and the data is pretty much normal. Let's do cubic. Okay, and now we are doing it cubic. Cubic is almost it's forming like curvature. You can see here this is almost like curvature. 93.2 is the r square, and adjusted is 91.1, and the data is pretty much residual plot. You can see here pretty much normal, and it is perfect. Now even it is great with the histogram and all that. So you can see here cubic also we have done, right? So curvature is almost close to that one, and this is cubic we have done. So the second example we have done successfully. Now the last and final example which we are going to discuss now. The last example to do with the delivery time and sorting time. What I will do, I will give control E so that this window will come up. I'm giving F3, and so that I can go back and taking this delivery time is an output and sorting time is an input. And I will do like same, and you can go to graph and then ask for 4 in 1, and then you can start with the linear one. So as you can see here, so let's see that graph and the session folder. Degree of freedom 1, and sum of square 401, mean square is 401, and f value, p value we have got, and error details we have got, and all this. So this is some values are being very much drifted, and 65.4 that is moderate. This is actually like above 70 is considered to be a good model. So in this case, it is moderate correlated, and adjusted is 63.8. So always adjusted is lower than the R square. And pretty much data is normal, and then horizontally, you can see here horizontally spread out, and then you can see that this has been perfect symmetrical, and you can see here the data is zigzag. So versus order. The same example, I'm going to do it in quadratic. Let's see the response. And now it is slightly better, right? You can see here. Maybe I will do here quadratic. The same equations, that is y equal to c plus m into sorting time. Again, you have these things into the 10 to the power of 2, right? 68.6. So initially it was 65.4. Now it became 68.6. Adjusted is 65.6. And pretty much the data is normal and all that, right? So the last and final example, and the same final method we are going to do is cubic, and let's see what the response we are getting in the cubic. So this is the cubic we have got. So you can see here, it is formed the perfect curvature, but some points are away. So that's the reason actually it still shows that good model, that 70.3, and adjusted is 65.8, because we have got more error there, right? So this is again the data is normal and it's been horizontally spread out, and it's the perfect zero, and then deviation is one, so it means it's a perfect normal data, normal distributed. And then this also shows that versus order shows that it is being spread out, in order wise and all that. So this is the one. So the final summary which I would like to talk about is, so this is the example of how the R square value sometime, in the particularly when you're talking about multi regressions, you also need to take a look on the adjusted value also as well. And we have done it. The famous model which we commonly use is a linear. Sometime in order to prove a better model, we may also use it quadratic and cubic also as well. I hope you enjoyed this video. Please do like, share, subscribe my channel. You have a wonderful day ahead.